the area between the x-axis and the curve of f of x equals 3 secant squared 3x. And we want to do that between 0 and 1. So first of all, we need to know what that 3 secant squared x function is going to look like. And secant squared is basically the secant function kind of all on above the x-axis. And we need to recognize that between 0 and 1, there's going to be an asymptote. Okay, so we want to know where the secant is going to be undefined, or in other words, where the cosine value is going to be equal to 0. So cosine is equal to 0 at 90 degrees and negative 90 degrees, or pi over 2 and negative pi over 2. And since we have the domain of 0 to 1, we only really need to worry about the pi over 2 value. So the angle 3x is going to equal pi over 2. So we're going to find our vertical asymptote at pi over 6. Okay, so there's our vertical asymptote. It's going to be right there. Okay, so I'm just going to highlight that. This is just finding the vertical asymptote. Okay, once I establish that, I need to recognize then that I have an improper integral. I have unbounded regions. So I have this unbounded region over here, and I'm going to need to write a limit form of this improper integral. So I'm going to do the limit as some value of a approaches pi over 6, and we're going to approach it from the negative side. And we're going to integrate from 0 to that value of negative pi over 6, and we're going to use the area under 3 secant squared 3x dx. We also have this unbounded region here on the right hand side, so we're going to need another limit for that. So it becomes the limit, and in this case we're going to approach the asymptote from the right hand side. So we're going to put a plus there, and it's going to be from that pi over 6 to 1 of the same integral. So 3 secant squared 3x. Okay, so I've now set up the integrals. I have used the limit, so I'm doing it formally, and now I can anti-differentiate this expression. Since secant squared is a derivative of tan, we know that the antiderivative of this must be tan. So when I anti-differentiate this, I'm going to end up with a limit as a approaches pi over 6 from the negative side, and it's going to be 3 tan 3x, and I have to divide by the compression of 3, so that 3's cancel out. So I end up with tan 3x, and I'm going to integrate from 0 to a. And then I'll do the blue side of this as well. So plus, and formally I need to use the limit as we approach the boundary from the right hand side this time. And we're going to have the same antiderivative, tan 3x. In this case, we're going to go from a to 1. Okay, so then I just have to plug in my values, and I can find the areas that I'm looking for. So when I plug in my bounds, I end up with the limit as a approaches pi over 6 from the negative side of tan of a. And I should really, I'm just going to actually just plug it in. I'm going to skip a step here. So I'm going to plug in that pi over 6 into the expression here. So I'm going to end up with pi over 2. And I'm going to be approaching pi over 2 from the negative side. Okay, and then I'm going to plug in 0 into that expression. So tan 0 is 0. And so I want to evaluate this. So I need to know what's happening as I approach pi over 2. The tan values I approach pi over 2 from the negative side. So if I think of the tan graph, there's my tan graph here. from the negative side of pi over 2, okay, and this is going to be approaching it from this side, I'm going to be going to positive infinity. So this is going to be infinite. Infinity minus 0 is just infinity. So this area, this unbounded area in red, is infinite. Then I can do the same for this limit over here. So I'm just going to plug in my value of 1. So I end up with tan 3 minus, and I'm plugging in the a value, so I get pi over 2. In this case, I'm approaching pi over 2 from the positive side. So if I take a look at the tan graph looks like this. From the positive side, it is approaching negative infinity. Okay, so in this case here, I get plus 3, or tan 3, sorry, minus negative infinity, which means that the unbounded region in blue is positive infinity or infinite. So when we put these two areas together, the net area that we end up with is infinity. Okay, so the area above the curve is going to be infinite because these are unbounded areas.